Told you I would be. All right, so in the first part of section 12.4, we did the law of sines and how you can use it to find missing parts of a triangle. And we did the angle, angle, side, and the angle, side, angle. Here we're going to do what's called the ambiguous case. That's when you have a side, and the non-included angle. A side, and the non-included angle. Now, in this case, unfortunately, we have to be careful because it will not always make a triangle. Even though I drew this triangle, it might not be one. Um, and you can have no triangle, you can have one triangle, or you can have two. So we're going to look at each case. I'm going to do an example of each. So if we start with this one right here. First of all, you have to look what you're given. I'm given 105 and 9, so I've got to use that because that's a given to me. Now, I don't have little t or angle s. But since I have the side opposite s, I can use this 6 and find that angle. So I've got sine of 105 over 9 is going to equal the sine of 105 over 9. I just said that. Hello, repeat, repeat. And that's going to be the sine of s over 6. And ignore that white out right there. I didn't make a mistake and start over. Okay, now I'm going to go ahead and solve this. So 9 times sine of s equals 6 times the sine of 105 divided by 9. Alright, so sometimes people like to see what I'm doing, so I'm going to show you. So I'm going to go 6 sine 105 divided by 9. Now I get that. So that's the sine of s. I'm going to go 4 places. So 0.64395 would go to 0.6440. 0.6440. Now, remember, that's the sine of s. So I know what the sine is. I need the angle, so I do sine inverse of 0.6440 is going to be s. All right, so when I do that, okay, second sine 0.6440, 40.09, so we're going to go with about 40 degrees, okay? So S is approximately 40 degrees. Boom. So that's good. So that means I got a triangle. So if S is 40 degrees, all right, then T would be 105 plus 40 is 145, which leaves us 35 degrees for angle T. Okay, now I can use law of sine again and say, now always go with what you were given. So sine of 105 over 9 equals the sine of 35 over t. Do the same math again, 9 times sine 35. And some of you will learn to do a little shortcut here. T times sine of 105 divided by sine of 105. Okay, so again, calculator, bring it up for you. 9 times sine 35 divided by, whoopsie, this is a sine of 105, moron. Sine 105, and I get about 5.3. Okay, so that means that little t is 5.3. So those are that's my missing pieces. I found t, s, and then angle t. Okay, those were the missing. Now, so that's one triangle. Now, how do I determine if there's two triangles? Well, here's the deal. Every sine, cosine, whatever actually has two equivalent angles with that same sine or cosine. Like if you remember when we did, I'm going to throw up the unit circle just as an example here to show you. Okay, see how, let's say, I don't know if you can see, hold it up a little closer to you. Okay, or you could just zoom in, French. So how about you do that? You know, make life easy on yourself. Let's see if this will work here. Let's see, zoom. All right, let's see if that works. Then I probably messed up the whole thing here, but we'll see. Okay, yeah, you're not going blind. So it's kind of hard to see still. But anyway, see right there, the cosine is negative radical 2 over 2. And if I go down here, the cosine, negative radical 2 over 2. And this repeats all the way around. So every sine and cosine is going to have two angles that will go with it. Okay, so that's what you got to watch out for. So here's what I got to do now. Okay, so I need to see if there's another angle that has that same cosine, or sine, not cosine, dummy. All right, so let's see if we can focus this back here. All right, so here's what I got to do. So I'm going to take my original 40 degrees. So the other angle that's going to have that same sine right there, okay, this gives me a first quadrant angle. It's a positive, so that's going to be in the second quadrant. So what's the equivalent of a 40-degree angle in the second quadrant? So what I do is I say my 180 minus 40 degrees equals 140 degrees. Now if I do the sine, I'm going to show you this. If I do the sine of 140, okay, so that's not exactly the same, but because we rounded, but it's fairly close. So that shows me that the 140 without rounding would have been the same angle. So now here's the deal. That 140 degrees plus my given angle, which was 105. Okay, if you look at that right there, that's 245 degrees. That's greater than 180. I can't have another triangle. 140 cannot be an angle in that triangle. So that's it. I have one triangle. That's the test. Once I find my one triangle, then I go back and I get the other angle that would have had that same sine, which is 140 degrees, put it with the given angle. Well, that's more than a triangle already. So, it's not going to work. Okay, so that's the case when you have one triangle. All right. Okay. So here we see another triangle, another SSA triangle. Okay, so again, we have to, it's possible there's no triangle. Miss French, you drew a triangle. Well, it doesn't mean that'll be a triangle. Like, I could just draw, anybody can draw a triangle and throw in numbers. So we're going to start the same process. Again, we got our given. So we go sine 35 over 17. We've got 20, so we're going to go to angle B equals sine B over 20, right? All right, do the math. So it's going to be 20 times the sine of 35 equals 17 times the sine of B. Divide by 17 this time. Okay. Again, let's do the math for you right here. All right, so clear that sucker. So 20 sine, make sure if you're not getting these answers with me, make sure you're in degrees, divided by 17. That's approximately 0.6747. So that's 9, makes that go to an 8. So that gives us 0.6748 is approximately the sine of angle B. Okay, so now we want to do the inverse. Sine inverse of 0.6748 is going to equal angle B. Now sometimes they'll call this like the arc sine, ARC. I don't know why, I don't know everything. But second sine 0.6748, and it's approximately 42 degrees. So angle B is approximately 42 degrees. So I got 42 degrees there. Add 42 and 35, that's 77. That would leave me 103 degrees here. So I know I got at least one triangle. And now I can find the other side of the triangle. Okay, so let's do, again, I'm going to go with what I originally had. Sine of 35 over 17 equals what? Sine of 103 over, what side is that? That's little c, over little c. Again, 17 times sine 103 equals c times sine 35. Divide by sine of 35. Divide by sine of 35. And so you can see again, 17 sine 103 divided by sine of 35, about 28.9. Let's see, what do we want to go with that on? Rounds that to about 29. We're going to the nearest tenth? We'll go with that. All right. So, what? 28.9, we'll go to the nearest tenth. So 28.9 is approximately little c. So that's 28.9. Okay, now let's see if we could possibly have two triangles. Because again, every value has, every sine, cosine, tangent has two possible angles that go with it. They're literally 180 degrees apart. So, like across the circle, so they're not 180 degrees difference in them. All right, so let's go back. What was our first initial? B was 42. So we go 180 minus 42. Okay, and that's going to equal 138. So now look, 138 plus our original angle of 35, that's going to be 138 plus 35 is 173. See, 173 is less than 180. So that means we have a second triangle. Okay? That means we have another triangle. If this is less than, we have another triangle. Okay? So just remember, when you add these up, if it's less than 180, that means that you have two triangles. So I got to find the other triangles. So, well, how am I supposed to do that, Mr. French? Well, if you know that this was 42, so that was good. So that means the other value for B, when we subtracted, was 138. Okay? So that means B, this B right here, let's call it B2, if you will. That can be 138 degrees. Okay? So that's going to leave us for C2. Well, let's see. So if this is 138, 138 plus 35, right? You with me? 138 plus 35, because 35 was our given. We already did that. That's 173. So that leaves us what for C2? 7 degrees. Okay? So that's 7 degrees. Now we have to find now little c2, the side of the triangle. All right, so let's go ahead and do that. Okay, so we got to use the 7 degrees now instead of the 30, not 35. We're still going to use instead of the 103. So we're going to go back and we're going to say sine 35 over 17 equals the sine of 7 over little c2, if you will. Okay? All right, so then we're going to do the same thing. 17 times sine of 7 equals little c2 times sine of 35 divided by sine of 35. Do the math. 17 sine of, whoopsie, 7. So again, 17 times the sine of 7 divided by sine of 35. We get about 3.6. Okay, so that would be our little c2. All right, so what we have here, guys, we have, I know it's a lot of information. So we had B. Oh, see, I'll put that up there. Somebody should have said something again. So we had B, and then we found C, which was the little side C. Found our other angle C. All right, and then we found B2 for the second possibility, and second possibility for angle C, and then the new value for C2. So that'd be two possible triangles. Okay, I know that's a lot, but practice it. I think you'll get it okay. So we've done one triangle, we've done two triangles. That only leaves us one place to go, and that's no triangles. Okay, so let's do that. I think you're going to like the no triangle one. I think we can fit it in right here. I know you guys yell at me about wasting paper. So, all right, so let's see. What do we want here? All right, so last one here. So again, let's look what we have. We've got our SSA again. So we got to check and see if we have one, none, or two. By the way, this guy had two triangles. I didn't write that down, but we found it. All right, so let's start it out. Sine of 54 over 6 equals sine of B over 8. Do the math. 6 sine of B equals 8 sine of 54. All right, divide by 6. Sine of B equals, pull it up the calculator, 8 sine of 54 divided by 6 equals 1.0787 roughly. 0.787. So we got to do the inverse since we have the value. So second sine 1.0787. Error. Okay, so we didn't do anything wrong. That's not possible. Okay, your sine and cosine can never be greater than 1. So plug it in the calculator, get an error. If you did everything right, that's good. You should have got an error. That means this triangle is not possible to draw. Even though I drew it, it cannot be a real triangle. Okay, so this would be no triangles. Okay, no triangles. Not gonna happen. All right, so practice on this. Again, all this is on eCampus, 819, 29 through 35 odd. I believe that's 4 problems. Guys, if you need help, you know I'm here. Make sure you contact me at least once a week. Hope everything's going well. If you have any questions at all or anything, just shoot me a text. See you next time.